Welcome to the History Loom. Today, we're going to take an in-depth look at the fascinating history of engineering. From the ancient world to the modern era, engineering has played a crucial role in shaping the world we live in. The journey of engineering is full of fascinating innovations, breakthroughs, and figures who helped build the very foundation of modern society. Let's explore. Engineering can be traced back thousands of years. Some of the earliest examples of engineering come from ancient civilizations, where the use of simple machines like the wheel, pulley, and lever laid the groundwork for complex structures and systems. In ancient Egypt, for example, engineers used ramps, levers, and sledges to build the Great Pyramid of Giza, one of the 7 wonders of the ancient world. The pyramid, which was completed around 2560 BCE, required a precise understanding of geometry and physics. In fact, it's estimated that over 2 million stone blocks, each weighing several tons, were used to build the pyramid, with engineers using simple machines to move and position these massive stones. Fast forward to the Roman Empire, and you see the development of monumental structures like aqueducts and the Colosseum. The Romans are credited with perfecting concrete, allowing them to build larger, more durable structures. The Roman aqueducts, some of which still stand today, were marvels of engineering, capable of transporting water over vast distances. The Pont du Gard aqueduct in France, for example, stands at 160 feet high and stretches over 30 miles, delivering water to the city of Nimes. Now, let's turn our attention to ancient India and the engineering marvels of its temples. Indian temples, built between the 5th and 12th centuries, are renowned for their architectural precision and engineering feats. One of the most impressive aspects of these temples is how they were constructed without the use of mortar. Massive stone blocks were precisely cut and interlocked through complex joints, allowing the structures to stand without any binding agent. For example, the Brihadiswarar temple in Tamil Nadu, completed in 1010 CE, features a 66-foot-tall monolithic dome carved from a single granite rock. It's so perfectly aligned that after more than a millennium, the temple is still standing with barely any structural deterioration. The famous temples of Khajuraho, Konark, and Ellora, built between the 9th and 12th centuries, showcase a level of precision engineering and artistic design that is unparalleled. The temple's intricate sculptures, astronomical alignments, and precision symmetry were made possible through sophisticated calculations in geometry and physics. Many of these temples also contained hidden mechanisms like water channels, pulleys, and counterweights to manipulate water during religious ceremonies, creating visually stunning effects during rituals. In fact, the engineering of Indian temples extended beyond aesthetics. It included hydraulic engineering. For example, the great reservoir at the Kailasa temple in Ellora was built using a complex system of channels and pipes to redirect water through various parts of the temple, creating an intricate display of movement and balance. This hydraulic system, coupled with the temple's carvings and sculpture, is designed to mimic the natural world and express cosmic principles, reflecting ancient Indian philosophies like Vasta Shastra and Sthapatya Veda. The ancient Indian temple builders also employed sophisticated stone cutting techniques that allowed them to carve fine details into large blocks of rock, which were then moved using a combination of wooden levers, ropes, and counterweights. This is evident in the exquisite reliefs and sculptures of Hindu gods, goddesses, and mythical creatures that adorn temples like the Konark Sun Temple. Each sculpture was crafted with great precision and aligned with astronomical patterns to ensure that they corresponded with the seasons and the solar calendar. One of the most impressive engineering feats of ancient Indian temples is their ability to maintain structural integrity across different weather conditions and geological settings. For instance, the Jagannath Temple in Puri, built in 1161 CE, stands on the coastal plains of eastern India, where it regularly experiences strong winds, heavy monsoon rains, and seismic activity. Despite this, the temple's design, with its interlocking stones and careful engineering, has remained largely intact for over 800 years. Fast forward to the Industrial Revolution in the late 18th century, and you begin to see similarities between the engineering principles used to build ancient Indian temples and the modern techniques that emerged with the steam engine and mechanical engineering. The precision in cutting, interlocking stones, and use of levers, pulleys, and counterweights were very much akin to the mechanical principles that underpinned the Industrial Revolution's machinery. As time went on, engineering evolved, driven by new technologies and the needs of societies. One of the major turning points in engineering history came during the Industrial Revolution in the late 18th and early 19th centuries. It was during this period that engineering, as we understand it today, began to take shape. The Industrial Revolution was fueled by innovations in machinery, transportation, and manufacturing processes. The invention of the steam engine was perhaps the most pivotal event of the Industrial Revolution. In 1712, Thomas Newcomen, an English inventor, created the first practical steam engine, which was used to pump water out of coal mines. But it was James Watt, a Scottish engineer, who made key improvements to Newcomen's design in the late 18th century, transforming the steam engine into a more efficient and practical machine. Watt's improvements laid the foundation for mechanized industries, and by 1800, steam engines were driving machinery in factories, powering ships, and even propelling the first trains. The steam engine revolutionized transportation and manufacturing, contributing to the rapid industrialization of Britain and the world. In parallel, electrical engineering emerged as another transformative force. In the early 19th century, Alessandro Volta invented the first battery, known as the voltaic pile, which created a steady flow of electricity. This invention paved the way for future developments in electricity and electromagnetism. Later, Michael Faraday's work with electromagnetic induction in the 1830s led to the development of the electric motor, which would play a crucial role in powering the machines of the future. The late 19th century saw the rise of major technological advances that laid the foundation for modern electrical engineering. In 1879, Thomas Edison perfected the practical electric light bulb, forever changing the way we live and work. Meanwhile, Nikola Tesla and George Westinghouse were pioneering the development of alternating current, AC, which allowed electricity to be transmitted over long distances, leading to the widespread electrification of cities and towns across the world. By the end of the 19th century, electrical engineers were designing power plants, lighting systems, and communication networks that would shape the modern world. The early 20th century also saw the rise of aeronautical engineering. The Wright brothers' first powered flight in 1903 marked the beginning of the modern aviation industry. The Wright brothers, Orville and Wilbur, were self-taught engineers who understood the principles of aerodynamics and built their own aircraft. By the end of World War I, airplanes had become a key part of military strategy, and aeronautical engineering was a rapidly growing field. The development of faster, more efficient airplanes continued throughout the 20th century, leading to the creation of commercial airlines and the modern air travel industry. Chemical engineering, another key branch of engineering, emerged during the Industrial Revolution as industries needed new materials and processes to support mass production. In 1887, George E. Davis, often referred to as the father of chemical engineering, developed the first systematic study of chemical processes. This laid the foundation for the creation of chemical engineering as a distinct discipline. The development of chemical engineering played a major role in industries such as pharmaceuticals, petrochemicals, and food processing, and has continued to be a driving force behind modern manufacturing processes. By the mid-20th century, aerospace engineering expanded into the realm of space exploration. The space race between the United States and the Soviet Union in the 1960s pushed the boundaries of engineering to new heights, with the ultimate achievement being the Apollo 11 moon landing in 1969. This achievement was the result of decades of research and development by engineers, scientists, and astronauts. The advancements in aerospace engineering from this era not only led to the first human landing on the moon but also revolutionized satellite technology and space exploration. The digital revolution that began in the latter half of the 20th century would forever change the landscape of engineering. The invention of the computer and the development of microchips led to the rise of computer engineering. In 1990, Alan Emtage created the first search engine, which laid the foundation for the information age we now live in. From that point on, engineering and technology would increasingly be intertwined, with advancements in computing, artificial intelligence, and robotics pushing the boundaries of what's possible. From the earliest stone tools to the creation of the Internet, engineering has been at the heart of human progress. The ingenuity of engineers throughout history has shaped our world and continues to pave the way for the future. As technology continues to advance, we can only imagine what the next chapter in the history of engineering will look like. Thanks for joining us on this incredible journey through the history of engineering. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon so you won't miss out on more fascinating stories from the past. What do you think is the next big breakthrough in engineering? Let us know in the comments below.